Hi everybody, welcome to Miss B's attempt at helping us review and learn AB stats while we're away. I hope that everybody is feeling well, and it's raining today as I do this. I feel like we're getting good days and bad days every single day, so I hope that this finds you all well. So the first thing I want to remind you of is what's the purpose of a significance test? Okay, so a significance test looks at what is the likelihood that if everything I think is true, number one, that I'm not lying. So remember, we're not lying, we're not faking it. We have met conditions. Remember, we have three sets of conditions that we like for proportions. We like a simple random sample. We like large counts. And remember, large counts is the n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Remember, and the last thing is independence, or the 10% rule. And remember, I mentioned multiple times that independence, or the 10% rule, is the one that in previous tests they haven't come down really carefully and been assessing it on the rubric for the FRQs, but they're going to this year going forward. And so that means that the sample size is less than 10% of the population size. And if you all remember, I kind of said that if my sample size is 10, is the population greater than 100? So if you add a 0 to your sample size, then that gives you perspective. And especially if they tell you something like a large high school, then you can say like, well, 2,000 is a reasonable amount of people, okay? So moving forward, we're not faking it. We've met some conditions, okay? And we're assuming that everything is being done kind of on a repetitive basis over and over and over again. And this is where significance tests kind of have gotten a lot of arguments out of science and industry, in that, well, I mean, you can say anybody's faking it, or you can say I'm not faking it. You can say that what I'm saying is the truth, or I'm not saying the truth. Everything's kind of a little arbitrary. But remember, we're just looking for following the procedure. Have they asked the question, is there evidence that? And then we can continue to move on. Okay. So what I want to do in this video is, you all have your Statsmatic packets at home, but just in case, I've actually imported the images into this file, and I will attach them to Google Classroom for you. Unfortunately, they're not the super cool edited versions that came with my beautiful image and my beautiful picture on them, because those were in a Word doc and those are on my school computer. So we're dealing with Chromebooks and iPads right now. So we're working with what Miss B's got. So for that situation, I want to move forward and do, in this video, 9.2 day 1 and 9.2 day 2. Unfortunately, we won't be able to do the Skittles as a class. I'm going to run the Skittle simulation randomly. So we'll see what happens. So let's move forward. Okay. So lesson 9.2 day 1. Are you sure? I'm pretty sure yours says Miss B isn't a good free throw shooter. And let's remember back for a second. We were talking about the fact that I am amazing at shooting basketball, and so therefore I make 80% of my free throws. But then when I was put to the test one day, I made 64%. And we ran some simulations and figured out what is the probability that that could actually happen. And you all figured out that if I really was an 80% free throw shooter, the probability that I would ever shoot 64% was either 0 or like, I think 1%, maybe. It was very unlikely to happen. Okay. And so that's where we use that sentence, assuming that the true probability, right, meets the criteria, then there's a 0% probability that Miss B can make a free throw. So what we're going to do here is we're going to actually carry out the steps of the significance test. And remember, a significance test is telling us what's outside of the expected confidence interval, whereas a confidence interval was telling us what might fall inside. And if it fell inside, then it was reasonable to say it was true. So this talks a little bit about in the simulation, we noted that Miss B was exaggerating about her free throws. Today we're going to use the formula to find the p-value. So we're going to do it by hand. We're going to carry out the significance test, and we're going to begin by writing hypothesis tests. So remember, the first thing I told you about hypothesis is your null hypothesis, h sub 0, is always the parameter value that we're interested in. And if you turn back in your packets to the first page, we figured out that that was the 0.8, which is what I said I did as the proportion of free throws. And then the alternative can fall into one of three categories. The parameter is less than the value, greater than the value, or not equal to. And as a class, we haven't had a lot of time to talk about the not equal to part. Hopefully I will kind of throw an extra video in here as we go. And I get better at this process because it's a learning curve for all of us. So for our situation, you all think I'm lying. So we're going to say that P is less than 0.8. When we did this, each of you did a different dot plot. You found out different values. But we said that in order to do this, the three conditions are simple random sample, large counts, and 10%. And when I talk about can I use a normal distribution, what is that alluding to? Well, that's alluding to the large counts. Okay, so it's alluding to large counts. And we that day did 50 free throws. So it's 50 times 0.8 greater than 10, and is 50 times 0.2 greater than 10. Now, the other day I said when I was grading your test, it was really important that you realized that I didn't penalize you on your last test for 50 times 0.8 is greater than or equal to 10, but I will in the future because that won't get you full credit on the AP exam, and that's not what we're looking for. So 50 times 0.8 is 40, and therefore 40 is greater than 10 is true, and 50 times 0.2 is 10, and 10 is greater than or equal to 10. That is true. Okay. Are there other conditions we need to check? What are they? Is it a simple random sample? Yes, it is. And is 50 less than 10% of all free throws that I could throw? Yep, we're good. Okay. Now that the conditions have been met, find the mean and standard deviation of the sampling distribution p hat. So this is key, guys. You need to go into your folder and you need to put your formula sheet beside you. You're gonna use it over and over and over again. And I'm so thankful that we spent some time looking at it. Now, I am gonna try to get a copy of the formula sheet up to Google Classroom for you so that in case it didn't go home with you, it got stuck behind, you're not lucky enough to have that trusty handy dandy yellow formula sheet with you. Okay, but on that formula sheet, there's a part under sampling distributions for p hat where we saw that the mean of the sampling distribution was equal to the parameter, which for us is 0.8. And the standard deviation of the statistic is equal to, or sampling distribution is equal to the square root of p times 1 minus p over n. And remember what we said is that if I know the parameter, I use p sub zeros or p's. When I don't know the parameter, FYI, or AKA confidence intervals, that's when we use p hats, okay? That's a big thing in your head to kind of start to separate. When do I know information about the parameter? When do I know information about the statistic? Okay, so we're going to use this mean and standard deviation, and we're going to label our curve down the bottom. So you're going to watch me do some math real fast. Okay, so when I did this calculation, I got 0.056 for my standard deviation. And remember back when we learned about labeling normal curves, we start with the mean, So this is 0.8. I'm going to need a finer pencil very quickly. Oh, I don't think that's what I meant to do though. Okay, we're going to work with what we got. And then we're going to add that value, 0.0565. We're going to add a 5 here. And we're going to get 0.8565. And we're going to add it again. And we're going to get 0.913. And we're going to do it one more time. And we're going to get 0.9695. And then we're going to come over here and we're going to subtract it. Having some issues with things blending. I apologize. Give me 1 second. I'm going to fix that to the best of my ability. So this is 0.7435. This guy is 0.687, and this guy is 0.6305. So remember, 1 standard deviation below the mean is 0.7435. 2 standard deviations below the mean is 0.687, and 3 standard deviations below the mean is 0.6305. Going above, 1 standard deviation above is 0.8565, 2 standard deviations above is 0.913, and 3 standard deviations above is 0.9695. Okay, so how many standard deviations below the mean? This is the answer for question 4. How many standard deviations for question number 5 below the mean is a z-score? Remember, we learned this. We learned that this meant z-score, and we keep using it over and over again, so don't forget that. So it's 0.64. Well, on your trusty dusty handy dandy formula sheet, you have something that says test statistic equals the statistic minus the parameter over the standard deviation of the statistic. Okay, so we're going to do the statistic, which is 0.64, minus the parameter, which is 0.8, over my trusty dusty 0.0565. And when I do that calculation, we find out that the z-score is negative 2.83. Okay, so let's look at our picture for a second. Where would that be? Well, that's going to be somewhere down here. And I want to shade, I said P was less than 0.8, so I want to shade over here. Okay, so bad job on my part, but that's okay. So find the probability of an 80% shooter making 32 out of 50 or less. That means we're going to go to our formula sheets. Okay, we're going to go to our formula sheet, and I bet if I do this well, watch and learn, folks, watch and learn. If I do this well, I'm going to go and I'm going to add okay. So what I did was I went to the College Board website and I found the formula sheet so we could talk a little bit about it before we go back to the top. So remember, as we go, that we are looking for, well, so we have a couple of things here that we want to look at. The first thing is this statement here, which is the standardized test statistic. Apparently drawing on a website, it's not really working out for me, but that's okay. Statistic minus parameter over the standard error of the statistic. That's the formula that we use to find our z-score. Okay. And then, oops, I want to be in here. Okay. So now we're going to scroll down. We also used this formula here, but we actually used this one, right? So I'm going to erase this one so you don't accidentally think that's the one we used. And we used the first one because we had the p-value, not the p-hat value. Okay, continuing in here. Scrolling down. All right, so this is what we were looking for. So we had a z-score of negative 2.83. Come on, computer. So negative 2.8. So we're going to highlight the negative 2.8 line, which is here. Okay, I'm not sure why it's doing that blue highlight thing. We're just going to deal with it. And I'm going to go to 0.03. And so this is the value that I'm interested in, which is 0.0023. Sorry for the randomness of it. Okay, so 0.0023 is what I'm going to use way back up at the top. Okay, so I came back up way to the top, and we're going to use that we got a p-value of 0.00. I just don't think it likes me today. I think it's unhappy with my video. This is going to say 0.0023, but apparently it's not. So let's see if I can write down here 0.0023. I don't know why it's not working. All right, so this is going to say 0.0023. Let's try this approach. 0.0023. There we go. There's what I was looking for it to do. And we're just going to move this all the way up here. So that's it. That's the problem. That's the solution to the problem. All right, so that being said, so 0.0023, I do apologize for that. So what conclusion can we make? This is where we need to be careful with what we say. What is the concluding statement? Okay. We have convincing evidence against the null hypothesis because 0.0023 is less than 0.05. And I'm afraid to write because we all know how my computer is functioning right now. So I'm going to try to type that in here for you. Okay. So we have convincing evidence against the null hypothesis because the p-value of 0.023 is less than 0.5, which is our standing kind of option for now. Okay, so we'll stick to that statement for now. There is definitely a better way for us to say this statement, but I want to start by just getting you this concept that because the p-value of 0.0023 was less than the p-value of 0.05, we can come to this conclusion. Okay. So big ideas, right? We need to find a test statistic. Big ideas. And we're going to try to write in the box. Let's see how this works out for us. One, check conditions. Two, write hypothesis. And remember that H naught is always a P equals, and HA can be a P is greater than, P is less than, or P is not equal to, okay? The other thing to remember here is that this, if I do this on my calculator, is called a one prop Z test, and it is option under stat, go over to tests, and it is option number 5 on our list. So now we're at the point where we know what A is, what B is, and option number 5 is. Okay. After I've checked conditions and written my hypothesis test, I'm going to calculate my z-score, or my test statistic, and then I'm going to compare the p-value, and then I'm going to write a conclusion. Okay, those are the things that we're going to go through and process. Okay. And just to help you out, I'm going to actually take a look at the check for understanding question and kind of walk through it. My suggestion is that you pause the video right now and that you do some of the check for understanding just to make sure. Okay, and then you come back. Okay, so taking a look at our important information. According to the U.S. Census Bureau, a proportion of students in a high school who have part-time jobs is 0.25. So that, folks, is going to be our p-value. So that is p equals 0.25. That is the population's parameter information. An administrator at a local high school suspects that the proportion of students at our school who have a part-time job is less than the national figure. She would like to carry out a test at the alpha equals 0.05 significance level. The administrator selects a random sample of 200 students from the school and finds that 39 of them have a part-time job. So that means that for us, this information, 39 out of 200, is what's going to make up my p hat. Okay, 39 over 200. So, state the appropriate hypothesis for performing the significance test. Be sure to define the parameter of interest. So, we need to say that the parameter of interest is the proportion of high school students who have a part-time job. And then we need to tell them that our null hypothesis is P is equal to 0.25. And according to the question they're asking, it appears that the alternative, the administrator suspects that the proportion of students at her high school who have a part-time job is less. So we're going to do less than 0.25. Okay. Explain why the results give some evidence of the example hat proportion. Well, that is because p hat, which is 39 over 200, is actually equal to 0.195, and that is way less in most people's minds of 0.25. Okay. So that's the answer to part B. Check the conditions. What are my conditions? My conditions say that 200 times 0.25 is greater than 10. 200 times 0.75 is greater than 10. Which, by the way, that's 50 is greater than 10, which is true. And 150 is greater than 10, which is true. It was a random sample. My pen does not like to write on the screen for some reason. It was a random sample, and 200 is less because a local high school, well, we're just going to have to assume here because it does not say, oh, less than all students in the U.S. Yes. Calculate the standardized test statistic and p-value. 0.195 minus 0.25 over the square root of 0.25 times 0.75 over 200. that was a mess. I apologize. When you do that, and I'll just tell you over here that my p hat for my standard deviation is actually equal to 0.25 times 0.75 over 200 is equal to 0.0306, and then this value works out to be negative 1.7973. Okay. What conclusion can you make? Well, the p-value is, if I go ahead and find the p-value, I come down here to my trusty table, my p-value for negative 1.79, negative 1.79, so we're on this line, and that's this last one down here, 0.0367. I just don't think it likes when I try to write p-values. 0.0367. So we can conclude that there is convincing evidence at the 5% level that there is convincing evidence against the null hypothesis because 0.0367 is less than 0.05. Okay. Why don't we call it quits there for today, guys? Have a great day.